Select the best reagents or set of reagents to accomplish the following transformation. So if we take a look at what we're starting with an ester. And what we're ending up with is this alpha beta unsaturated aldehyde. So we've got quite a change in functional group here. So what we've got going on is we're actually bringing together two equivalents of our starting material. But there's gonna be an intermediate. So what we wanna recognize is when we have this alpha beta unsaturated aldehyde, that this is the product of an aldol condensation reaction. So an aldol addition reaction is where you bring together two equivalents of the aldehyde. So one is the enolate, one is the aldehyde. In an aldol condensation reaction, you do that, but then you eliminate to lose water. So the immediate precursor to this alpha beta unsaturated would be the aldol addition product. So let's look backwards at that aldol addition product. So this would be your alpha carbon that attacked, which means this was your carbonyl carbon. So this is where you would have had the alcohol in your aldol addition product. And then we have this 2 carbon atom chain. So what we want to do is to take this aldol addition product, which was the immediate precursor to the condensation product, and break this backwards. So hopefully we can see that this is where your new bond is formed in your aldol. So we've got this 1, 2, 3, 4 carbon atoms there. 1, 2, 3, 4. So the alpha carbon of one carbonyl attacking the beta carbon of the other. And so hopefully we can see that these are these same 4 carbon atoms. So to do the aldol, you need not the ester, you need the aldehyde. So we're going to break this backwards to the aldehyde. So we have 1, 2, 3, 4 of those. So technically we do have 2 equivalents of this ester coming together. Don't get hung up on that stoichiometry because as long as you have more than one molecule all the time, you have a ton of the same molecule in there. So you definitely have enough to have these come together to form the product. And I guess I can number the 4 carbon atoms in this product as well. So you can see there's 1, 2, 3, 4, 1, 2, 3, 4. And so we can start thinking about how we can connect this aldehyde back to the ester. So hopefully you remember that an ester can be reduced and it can be selectively reduced to give you the aldehyde. So you need the right reagent to go from the ester to the aldehyde. And so the reducing agent we saw that was selective to do that was dibal. So in the first step, you're going to need the dibal-H, so diisobutyl aluminum hydride, and this is done at a low temperature with an aqueous workup. So with this, we can probably with confidence say that we're looking at A because this is the only one that involves dibal. But we should make sure that we understand all of the steps. So to get these to come together, this aldol addition reaction, that can be done under acidic conditions or basic conditions. So you can have some sort of base here to do this. And so in the case of A, it looks like we've got sodium methoxide. So that's about the equivalent base strength to the hydroxide that we've seen in other examples. So something along those lines would be able to get this aldol addition reaction to occur. And then to get this condensation, you can either continue just start heating it in this basic solution, or a lot of times we'll show acid and heat to do that dehydration. So a little bit of acid and heat will cause the dehydration to take place. And that converts from your aldol addition product to your aldol condensation product.